Hi, I'm Liz Sneddon. Let's have a look at the inverse binomial distribution. So here we're going to be given a probability and asked to find one of the parameters. So we need to know what's the probability that x is equal to 0, and we need to know one of the two parameters, and then we can work out the other one. So here's an example. So company sells packs of 10 pen drives. So that's our number of trials, or our sample size 10. Customers return 14.9% of them because it contains at least one faulty flash drive. So that's saying the probability that x is bigger than or equal to 1, that probability is 0.149. Okay, and we want to find the percentage that are faulty. So that means we want to find the parameter p. Okay, so first thing that we're going to do is the hint that I gave on the previous one was that we need to know the probability that x is equal to 0. So if I know that the probability that x is greater than or equal to 1, so that probability, if I know that is 0.149, then I also know that the whole probability has to add up to 1. So in order to find the chance of 0, I can do 1 minus that 0.149, and that will tell me the remainder. So that's what I want to do first. So to find the probability that x is equal to 0, it's 1 minus the probability x is greater than or equal to 1. So 1 minus 0.149 gives me a probability for 0 of 0.851. Okay, now what I want to do is I need to use my formula. So probability x is equal to 0. So I need to do n, which is 10, so 10 choose 0. Probability, which I don't know, to the power of 0 times 1 minus the probability to the power of 10 minus 0. So let's see if we can simplify this a little bit. Well, I know the probability x equals 0. I'll work that out just over here. That's 0.851. So let's put that in place. Anything choose 0 is always going to be a value of 1. And equally, p to the power of 0, anything to the power of 0 is always equal to 1. So both of those terms cancel to just 1s. So I'm going to be left with 1 minus p to the power of 10. So this is what I need to go and solve. So let's just jump over and get some more space. So I'm going to get 0.851 equals 1 minus p to the power of 10. So let me sidestep for a moment. If I had x squared equals 25, to solve that we would take the square root. We'd say x is equal to the square root of 25, which is 5. If I had x cubed equal to something, its inverse or opposite is the cubed root. If I have therefore something to the power of 10, so I had x to the power of 10, its opposite would be the 10th root of that. So that's what I'm going to do, is I'm going to apply the 10th root to both sides so that I can get rid of that power. So I'm going to get the 10th root of 0.851 is equal to 1 minus p. Okay, so now I can actually get rid of those brackets, 1 minus p, and that's equal to the 10th root, which will be a number. And when I put that into my calculator, let's go and do that. So I want to go, so I type in 10, and then to get to the root, I want to do shift, and then the little caret key, and just above that, it's got the little root x button. So that's what I want. I want that root x. So the 10th root of 0.851 is 0.98399. So let's make that 0.9840. So 0.9840 is equal to 1 minus p. So now what I need to do is I want to get the p by itself. So I'm going to rearrange this equation, and that will give me p equals 1 minus 0.984, which is equal to 0.016. Now if I just jump back to the question itself said calculate the percentage of flash drives that are faulty. So let me just turn that into a percentage. So multiply that by 100, and that's going to give me 1.6%. So 1.6% of drives are faulty. And that's answered our question. Let's have a look at a different way now. So that was looking at if we were solving to find the probability. Now let's see if we have a different problem. So this one, they said they want to reduce the number of flash drives returned to less than 10%. So they want the probability that X is greater than or equal to 1, so the chance of 1 or more being returned, they want that probability to be less than 10%. Okay, so we know that 1 minus the probability that X is equal to 0, that's equal to the probability of X being greater than or equal to 1. So we can use that to work out an expression for the probability that X is equal to 0, because that's the thing that we want to know. So the probability that X is equal to 0, we want that to be so that is going to be less than 90%. Okay, so let's think about what else we've got here. Given that they use the same flash drives, 1.6% are faulty. So that tells our P parameter is equal to 0.016. And we want to find the maximum numbers that can be put in each packet. So we want to find N. So that's what we're trying to work out. Okay, so we'll do some working here. So we want this probability that X is equal to 0. Now remember, N choose 0 will go to 1, and our probability of 0.016 to the power of 0 will also go to 1. So then we've got our 1 minus 0.016 to the power of n minus 0. And so we want this to be 0.9 is more than, those cancel, well those go away to 1, so I'm left with 1 minus 0.016 to the power of n. Now let's just move over to another slide and get some more space. So we're going to get 0.9 is greater than 1 minus 0.016 all to the power of n. That's where we're at. Okay, so let's simplify the number in brackets. 0.9 is greater than or equal to 0.984 to the power of n. Now what I want to do is I want to get that n out of being a power. So the opposite of a power is our log. So this is what we're going to do, and I'm going to apply the log function to both sides. So I'm going to get log of 0.9 is greater than log of 0.984 to the power of n. There's another log rule that says if I have a power, I can move that to a constant. That's the same as multiplying by that constant. So log of 0.9 is more than n log 0.984. Now I want n by itself because that's what I'm trying to solve. So let me get rid of log of this number. So I'm going to get log of 0.9 divided by log of 0.984 is greater than n. Now I need my calculator. Okay, so I want to, oh, I don't want that, go away. I want to do 0.9, log of 0.9 divided by log of 0.984, and that gives me a value of 6.5. So I'm going to say 6.5 is more than n. Flip that around, n is less than 6.5. So the first value below that is 6. So the maximum number I can have in a packet is 6. Okay, so that was the first part of the question. Now the second part said to calculate the percentage of new packs that will be returned because they contain faulty flash drives. So we want to find what's the probability that at least one will be returned if we now have this number of trials at 6, our probability of a faulty drive is 0.016, and we want to know what's the probability of more than 1 being returned. So 1 minus, excuse me, the probability x is equal to 0. So we're going to get probability x is equal to 0 equals 1 minus what am I doing? Okay, so we're going to get 1 minus, and we do need to do n, which is 6, choose 0, times the probability, 0.016, to the power of, where's my formula gone? Sorry, I just had a mind blank. It's to the power of x, so that's to the power of 0, times 1 minus the probability to the power of n minus x. N is 6, 6 minus 0. Okay, so that's going to give me 1 minus, and that's when I need to go and calculate all of that. So I can do, now 6, anything choose 0 goes to 0, goes to 1, anything to the power of 0 goes to the 1, so I'm going to have 1 minus 0.016 to equals 0.984, and do that to the power of 6. And now I need to subtract that from 1. 1 minus that answer gives me 0.092. So 0.0922, which is 9.22%. Thanks very much for watching.